Section 5.5, theorems about roots of polynomial equations. We're going to solve equations using the rational root theorem and the conjugate root theorem. They sound hard, but they are not. So just don't let the theorem word scare you. I'm going to look at just the examples here. I don't know that I would write it down word for word unless after the example you need it. You won't ever have to state it. It's just you have to know how to use it. So an example probably would be good. Put rational root theorem and then put the examples maybe underneath. What we're going to do is, do you remember the questions the last few weeks that I wasn't maybe as selective as I should have been? There was that one day when none of the ones on the page were things that we had done yet. This is going to help you figure out answers to those kinds of questions. There is factoring by grouping, which we didn't do, but I don't know that we necessarily have to. This will kind of get us kind of around that using things that we already know. So what we're going to do is we're going to get everything in descending order just like we have been. We're going to look at the one that's in front, the number, and the one that's last, the number there. Then we're going to divide them as many ways as we can to find out what the possibilities are. So that's the first thing. And then how do you narrow down those possibilities to actually get the answers? So just so you know, you can't use this on the test that we just took, even though that would be great, but you can't. Okay, so finding a rational root. Okay. And all we're looking for are what are the rational roots of. So we want to know the whole long list of things that could go in here. We're not looking for the answers on this one. We're only looking for those rational roots. So everything is on the same side. In descending order, we are looking at this number and this number. Okay, that's the only two that really matter in how we kind of go about the rest of this. So we're going to do the factors of 2, and I'll kind of be real mindful of what I write down so you guys can kind of figure this out if you have to look back at it. Let's go, factors of 2. Okay, obviously the factors of 2 are 1 and 2, but they could be plus, they could be minus. Okay, so I'm going to put plus or minus 1, plus or minus 2. So I could do 1 times 2, I could do -1 times -2, and those are basically the factors. You don't have to keep them together, you're just looking for the numbers. Then we're going to do the same thing with 5. Now it makes it really easy when the numbers are prime numbers, so we don't have as many. But what if you had the number 24? You'd have 1, 2, 3, 4, 6, 8, 12, 24. That's a lot of numbers, and 24 isn't that big. So when the numbers get bigger, you have way more options, which makes it a little trickier. They're using a pretty basic example this time. So now I'm going to do factors of 5, which is basically the same thing. We have 1. It could be plus or minus, and we have 5. It could be plus or minus. Oh, I don't know where my, okay, there it is. I was going to say, I don't know where my words went. So if you are looking in your book, here is where I'm looking. And I guess I can page up a little bit again. So we have found the factors in looking at this thing right here. They looked at the factors of 21, which we did. Ours was 2. They have more because it's 1, 3, 7, 21, and you need pluses and minuses ahead of each. Then they did factors of 10, 1, 2, 5, and 10, plus or minus in front of each. Now we're going to do something with those. It says the rational roots have a reduced form, so we need to kind of put all the numbers together that we can. The P is on the top, the Q is on the bottom. So how do we do that? I'm looking at anywhere that you guys would know which one that is. So take a look at problem 1, page 313. You're going to do the second one over the first one. Hold on. I got to get my glasses because that's too small. No. It's the constant term over the leading coefficient. That's how you set them up. So let me write that down here. Oops. Okay, so that's what I'm looking at on this one. So we're going to do that now. So what one is P, 5 or 2? Which one's the constant term, 5 or 2? 5. So we're going to do the one at the end, the one at the right, divided by the one at the left.
Is it constant because it has no other things?
No variables, yep. So I'm going to label these. This one is constant this time. This one is lead coefficient.
What happens if they have a variable? Would you take out like an x?
It would be like a 0 and they wouldn't have that because there wouldn't be anything there. So it's not always the last one. If the last one had an x in it, the constant would be a 0. But you could divide by 0, but that wouldn't make sense. So you're more than likely going to have a number there. Okay, so let's set these up. We have positive 1 over 1. Okay, so I looked at the second one and I divided by the first one. We're going to do all the possible combinations. I'm going to set it up like this first, but then I'm going to list them all. So the constant term goes on the top. The lead coefficients go on the bottom. Now I'm going to list them all. And if you want to do 1, -1, 5, -5, go for it. That's what it means. And I'll maybe do that so you know what I'm doing. And on the bottom, same thing. 1, -1, 2, -2. And they're all separate numbers. It's not one thing combined. So I'm going to take them one at a time. I'm going to start with my 1. I'm going to go 1 over 1 is 1. Okay? 1 over -1 is -1. Okay, so all I'm doing is taking this first number and putting it over each one of those. Okay, so then I have 1 over 2. Yep.
Can't you have like 5 over -2 and then -5 over +2? Or do you not have to write?
Yep, we haven't gotten to those yet. Yep, we're getting there. So all I've done is one number, and there are 4 options right now for that one number. Now I'm going to jump to the next one. Now some of them might be repeats now because the numbers kind of are the same. If it's a different sign, you have to write it, but if it's a repeat, you don't. So now I'm jumping to the -1. Do I have a -1 divided by 1? That's -1. I already have it, so I don't have to do that one, but I'm going to do the next one. -1 over -1 is 1, so I'm not going to write that one because we already have it. Do I have a -1 over 2? Yep. Do I have a -1 over -2? Yep. So basically, my 1 and -1 kind of were the same, so I didn't have to write them. But now Avalon's question, I'm going to get to the 5. I'm going to do the same thing with my 5. So I'm on 5 over 1. I don't have that one yet. 5 over -1. I don't have that one yet. 5 over 2. And 5 over -2. And I bet when I do my -5, it will be repeats of these, but we'll check them out anyway. -5 over 1 is -5. I already have it. -5 over -1 is 5. I already have that one. -5 over 2 I already have, and -5 over -2 I already have that one. You don't want to list them multiple times because that just takes too long. Now, this is the answer to this question. So, what are the rational roots of this equation? What that means is these are the possible numbers that could make this one factor nicely. It doesn't mean they're all going to work. It just means these are our possibilities. Now the next question is going to say, how do we take all these and find out which ones work in a fast way instead of trying them all? Okay, because we don't want to do that. We don't want to take a lot of time to do what we need to do. Here's kind of the steps. Now, I don't know why these got off, but here's kind of the steps that you're going to take. So at the top, once you find your possible roots, do these steps, and I think there's 3. You're going to use synthetic division to factor it, okay, which is what we were just doing on the test yesterday. So we're going to keep on doing that. So these are probably going to be more than quadratic equations that you're looking at. They're going to be cubes to the 4th, to the 5th, whatever. It doesn't matter what they are. We can do all of them now using this. Okay, so once we find one, and you wouldn't necessarily, unless it asked you to, you wouldn't necessarily have to list all the roots every time. Okay, for me, I don't like doing fractions, so that probably wouldn't be my first choice. But sometimes it gets down to those fractions that are the only things that work. And I'll show you how to do that in a minute. Step 2, continue finding roots and dividing until you have a 2nd degree polynomial. So if you start out with something to the 4th, you're going to go, I'm going to check this one to see if it goes in there. If it doesn't, I'm going to check this one to see if it goes in there. You're going to keep going and keep dividing until you get something with a 2, which is quadratic, and then we can factor it. And then once we get to that quadratic part, we can use the quadratic formula just like we've been doing. So we really have the tail end part done. It's just how do we get to that point is what we're going to practice. And that's what we're going to do next. Thank you. And looking at the steps, you're probably going, oh my gosh, this looks like it takes a long time. It doesn't. It really, really doesn't. If you had to do long division, yes, it would take a long time. But with synthetic division, it takes you just seconds to find out, does this one go in or does it not? So when we were looking at, is there a remainder or is there not? If there's a remainder, it's not a factor. It doesn't go in there. Skip that one. Go to another one. You're going to keep going until you find one that gets you a 0. It doesn't matter if the one I find is different than the one you find, because at the end, the answers will all be the same. Okay? So if you had an equation that had -2, 3, and 4 in there, let's say I chose 4 first and I found it, and you chose -2 first and you found it, eventually our answers will be the same. Okay, and that's the nice thing about this one is that you don't have to do exactly the same thing as someone else, but eventually you all get the same answers. Okay, so here we go. This one we're going to do the entire thing so you know kind of what to do at the very, very start and what not to do. So we first make sure everything's on the same side, which it is, and everything's in descending order, which it also is. So I always do P over Q like right away, but I'm not going to list them all this time, okay? So which one is P, which one is Q? P is 2. So I'm going to put my factors of 2 on the top. I'm going to go P equals 2, Q equals 15. Okay, so P over Q is plus or minus 1, plus or minus 2. Then I'm going to look at my Q, which is 15, plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. That's a lot of numbers. I do not want to list them all, nor do I want you to. Unless it says, give me all the possible rational roots, then you don't have to. This is good enough. Even if the book tells you you need to, not a big concern of mine. You just need to pick one to get started. Now, we're going to do some synthetic division, which is easy, okay? So this is the easy part. I'm putting everything in there. I just haven't decided which one I want to pick. You can pick any one of these. So maybe we want to pick 1. Okay, so you're going to pick one of these numbers on the top, one of those numbers on the bottom. Just keep track of which ones you do, and it'll be on your paper, so it doesn't really matter. I'm going to try 1. So I bring my 15 down. Remember, that number doesn't have to be a 1 all the time.
Are you picking from the P's or the Q's?
P over Q, 1 from each. Just like we did when we listed them all. You're going to pick one of those numbers. So up here, if I was doing the same question, I would be picking one of that list. If it helps you to write them all down, by all means write them all down. So I'm choosing 1 because that's the easiest one. I'm probably not going to do the fractional ones, but that doesn't mean that the fractional ones aren't the answer. Okay, so I'm picking one of them. And now I'm multiplying and adding. What is that, negative 17? Okay. So, did I pick the right one? No, because what we want is we want a 0 right there. Okay, so not the right one. I'm going to just go like this and just make a mental note. 1 is not the one. We're going to do another one. What numbers do you guys want to try?
5.
Okay, let's go 2. I heard that one first. I'm going to go over here. I'm going to go 2. Okay, so same setup. And I'm going to show you one other way that you can do this without doing the whole synthetic thing. But I just want to show you that this is an option. Okay, so we bring the 15 down and we multiply. That is the one. Now, is there another way that we can find out if it's a 0 really quickly? Can we plug the number into the original? Yes, you can do that too. So over here, we could have said, what is P of 1? Substitute in original. And you would have gotten negative 12, and you would have went, nope, that's not the one. So you wouldn't necessarily have to full out do the synthetic right away. But if you did P of 2 and you got a 0, then you'd be like, yes, I want to do synthetic division on that one. Okay, but you can do synthetic just to get it because it doesn't take that long anyway. And sometimes plugging the numbers in is harder than doing synthetic division. Honestly, we have a lot of trouble with signs. We have a lot of trouble with cubes and all that kind of stuff. Yep.
So the number you pick has to be the same on both.
No. I could have put in 1/5 if I wanted. Is that what you mean?
Yeah, like, can you pick 5?
It has to be a 1 over 5. So it has to be a number on the top with one of the things on the bottom. Okay? So if you were picking the 5, it would have to be 1/5 or 2/5 with signs as well. Okay, so the good thing is we found this one. So now what I'm going to do is, if I picked 2, what is the factor that makes a 2? We would have, for instance, x equals 2, right? To make it into a factor, it looks like x minus 2. And then we have this next to it, 15x squared minus 2x minus 1. Now, would we have ever come up with that if we were trying to factor it? No. Now we're going to keep going. What can I do to the thing on the right?
Wait, how did you get the second division to 2x squared minus 2x? Oh, no.
Okay.
Wait, how did you get the first?
2.
Oh.
X equals 2. Turn it into a factor. Okay. What would you guys do with the 15x squared minus 2x minus 1? Swing it. Or quadratic. I would swing it because this one definitely works. Okay. So if we do that, we get x squared minus 2x minus 15. Then we get factors of negative 15 that add up to 2, which are what? So we have, which one's negative? And then we swung the 15, so we need to swing it back in, which gives us x minus 1/3 and x plus 1/5. And what do we do with those? Swing them back out. Okay, so I'm bringing everything together right now. So remember those that we couldn't factor before? Now we can. And it's not that hard once you know kind of what to do. Now, we want to solve for them though. This is factored form, now we need to solve. So would we have had to have written it in factored form first, or could we just say this one's 1/3 and that one's negative 1/5? You can, but if you have to do factors, you know, I don't know if there's anything that asks you to, but if we solve them, we get x equals 2, 1/3, and negative 1/5. Now let's just take a sneak peek to see if those were choices that we would have had up here. If I look at my list again, 2 is 1 because there was a 2 on the top and a 1 on the bottom. 1/3 is 1. I would have picked the 1 from here and the 3 from there. And negative 1/5 is also 1. I would have chosen the negative 1 here and the 5 on the bottom. Again, most of the time they're not all fractions, so you can get there without picking those weird fractional numbers. I wouldn't pick 1/3 if it was me. You know, why would you guys? But can you do synthetic division with fractions? You can, it's just not as pretty. You know, so it works if there's no other options, but there's always going to be a whole number probably that does work in there. Okay, did anybody have any questions about that? So the only real thing that was new is how do you get the actual numbers that you might have as an answer, and then either plug it in to find out if there's a 0. If there is, do synthetic division on it.
If we wanted, because like I still don't get how you get the Q's and the Q's. Like I get 2 and 15.
Yep.
Is it just finding factors of 15 that add, or factors of 2 that add up to 15?
No.
I mean,
They have nothing to do with each other. This top number is factors of 2. The only numbers that make 2 are 1 and 2, but you can have either sign.
so if we wanted to do like a chart or something,
You could.
like
You could.
1 times 2, like actually write
You
that
could.
out.
You could. And then you're doing factors of 15, so they don't really have anything to do with each other. 1, 3, 5, 15. So 1 and 15, 3 and 5. Okay, and you're using all of the numbers, both of the signs. Okay? Okay. Now, the conjugate root theorem is another one of those theorems. Don't let the words scare you. We've already worked with conjugates, right? When we had a square root in the denominator, we multiplied by the conjugate, which is the opposite sign of it, right? That's kind of what conjugates are. So instead of writing all the words, let's do one. So do this one instead. You can go back and fill that in if you want to. I don't ever make you restate theorems, so again, it doesn't matter as long as you know what you're doing. A quartic polynomial has rational coefficients. If square root of 2 and 1 plus I are roots, what are the 2 other ones? Okay, so if I have square root of 2 as an answer, what's the conjugate of square root of 2? What's the conjugate mean again? Opposite sign. So if square root of 2 is an answer, negative square root of 2 is an answer as well. It's automatically that. If 1 minus I is a root, or 1 plus I is a root, what's the conjugate of 1 plus I? No, just the sign in the middle, remember? We did these, gosh, probably was it a month ago we were working with conjugates, I think. I think we were. I don't remember what section it was, but those are conjugates of each other. Okay, only change the sign in the middle. If there isn't a middle, it's the one ahead of the number. Now, these are rational coefficients that we're talking about, and we're going to do another one. It doesn't say you have to do anything with them at this point. It's just, what are they?
That's our answer?
Yeah,
Oh, okay.
that's it. Right there.
Wait, do we need to write like the conjugate?
Nope,
No.
you just need the numbers. That's it. Okay, so that one was not bad, was it? Okay. Okay. So if we were wanting to find a quartic polynomial, we could like multiply those all out, couldn't we? We could go x equals square root of 2, and then we make it into a factor, and then we multiply them all out. Takes a little while to do. What would our exponent be on that one if it was quartic? 4. So at the end, you would have an x to the 4th as your highest thing. It probably would have regular numbers, not square roots of numbers in it anymore because they multiply out. Okay. What is a third degree polynomial function with rational coefficients so that p of x equals 0, that's just our equation equals 0 at the end, has roots -4 and 2i. And if you're following along, we are on 314. 314 right in the middle, actually at the bottom. Now, if it's third degree, how many answers do you have? 3. So keep that in mind. So this is a third degree, 3 roots. Okay, so if I do conjugates of both of them, how many answers would you have? 4, right? So you don't always want to do both of them. You are looking for the rational ones, okay? The goofy ones that look like that, or the square root ones that look like the ones we had before. Those are the ones that you do conjugates of, okay? So far my answers are going to be these 3 numbers. -4, 2i, and what's the conjugate of 2i? Those are my 3. Now I'm going to multiply. Okay, so we need factors. Remember to do factors, you're starting kind of like this. You're bringing everything to the left. So I added 4 on this one. I subtracted 2i on that one, and I added 2i on the last one. It equals 0, just like they told us, and now we will multiply them. Okay, so it's kind of like a FOIL. When we multiplied these before, we were selective, or I am, because I don't like to do a lot of extra work if I don't have to. When I'm looking at these, I'm kind of spotting these because they're opposites of each other, right? If you do the opposites first, you will eliminate so much multiplying you have no idea. Because you're going to eliminate those middle terms right away, and you won't need to include them every time you do it. So I'm going to do those 2 first. You don't have to. You still should end up with the same thing, but you might get lost in the middle somewhere. So x times x, and we're just using FOIL, is x squared. X times positive 2i. I'm going to write this off to the side because I already know it's going to cancel because they're opposites. X times 2i would be 2xi. Then if I do the inner ones, I do negative 2i times x. That would be minus 2xi. They cancel every single time if they are opposites. Then I'm going to go to the last terms. Negative 2i times negative 2i would be negative 4i squared. Now, when I do these, I change that I squared out right away, but I'm going to leave it and I'm going to do it in another step just so you know you have to do something with it. So I'm going to go x plus 4. And then what's a I squared equal? A negative 1, right? So I'm going to remove that I squared and change it to a positive 4.
So you would just, like, to get the positive 4, you just get negative 4 times negative 1.
Yes. Yep. So basically, I'm converting my I squared into a number, and the value that I squared stands for is a negative 1. So I'm substituting the negative 1 in there, and negative 4 times negative 1 is 4. Because you don't want those i's left in there because you're going to have to do a lot the next time. Now we have to multiply these two, so we're going to do that. FOIL. X to the 3 plus 4x plus 4x squared plus 16. And I'm going to reorganize them so they are in descending order. Now, in the book, they had a multiple choice question. I just didn't want to type the choices. Our answer matches C. And that's what the answer is. So, yep.
So the only difference between, like, this one and, like, the last one that we did a few lessons ago was, like, there's just an extra variable though?
Yeah. There'll be maybe some i's in there that you have to reduce out. That's the only difference. So you guys have the multiplying already. You already know how to make them roots and make them factors. You just have to now multiply weirder things. Okay. Trying to decide if we have enough time to do this. I think we do. This one, Descartes' rule of signs. This is kind of one of those checking things, and you guys can write the theorem down. I'm just not going to sit right there for a minute. If you had answers, how do you know how many positive answers you should have or how many negative answers you should have? That's what this thing does. So the theorem helps you, you kind of check your answers to see if that actually makes sense. So we're going to find out first how many positive real answers. And if you're looking at the theorem, that's this right here. I'm just not going to do the words because we can all get lost in the words. Okay? What we're going to do is look for sign changes. Okay? So the positive real roots are the number of sign changes in the equation if everything's in the right order, the original one. Okay? So the sign ahead of this is positive, right? There's a sign change here, right? Goes from positive to negative. Is there a sign change there? Yes. So how many is that? 2. Okay, can we handle that? Yeah. Now, the only thing that the theorem makes it confusing is you have more than one option. So when you get your 2, you're going to subtract 2 from it because there could be 2 or they could be 0. I'm going to go 2 or 0. So once you get your number, subtract 2 until you hit a negative number or 0. Because we don't want negative numbers. We can't have like negative solutions, like negative numbers of solutions. So at the end, if we did this whole thing and we got all our answers, we could have 2 positive answers or we could have no positive answers. That's the only thing that this tells us. Now, how do you get the negative ones then? we're going to plug in a negative x into the original equation. And all I've done is just substitute it in right now. I haven't even simplified yet. And then we're going to do exactly the same thing. So the positive answers you get from the one that's given, the negative answers you get from plugging in a negative x yourself. So when we do this, do we get a positive answer or a negative when we plug a negative in and cube it? Negative. So I'm going to simplify now. So we get a negative x cubed. When I take negative x times negative x, does it change it? No, but there's a negative out in the front. So I have minus x squared plus 1. Then I'm going to check my sign changes and then I'm done. So is there a sign change from negative to negative? No. Is there one from a negative to a positive? Yes. So how many are there this time? 1. So if the sign is the same, don't mark it down. If it's different, then you do. Yep.
I thought like when there was a negative in front of like parentheses like that, the negative, and then parentheses, negative x.
No, it goes in the parentheses both times. Like if you're plugging in a negative x, you mean? It goes. This one? It is, but what about that? Oops. So here, right here, gives you x squared, right? But this keeps it negative. It doesn't cancel like over top of a parenthesis is what I'm saying. You were thinking the negative and the negative cancel before you square it? No, don't go over top of a parenthesis. Now, if I subtract 2 from that, what do I get? Negative 1. We don't want to go negative. We only want to hit 0. We don't want to go negative. So we have 1 negative real answer. Okay, so if we solve this one, we'd have a negative answer for sure, and then we'd have either 2 or 0 positive answers. Basically what it's going to do is it's going to check. Once you've solved these, it's going to check to see if your answers are okay. Av.
So the side note, when you said, okay, so once you get your number, subtract 2 from it until you get 0.
Yep.
So let's say you have 6. You have to subtract 2.
Until you hit 0. So you'd have 6 or 4 or 2 or 0. You have to do, yep, you're going to write all of them. If I had 5 negative real answers, I'd go 5 and 3 and 1, and then I'd hit a negative number, so I don't want that one. And you'd list them all.
You stop at
1.
1?
Yep.
But it's not 0 then.
It's 0. It's either 0 or a negative number. You don't want to do the negative numbers. It doesn't have to hit 0, because it won't sometimes. If you start with an odd number and keep subtracting 2, you're never going to hit 0.
So you'll get to the lowest you can go
Yeah.
before you hit a negative?
Yes. Yep. Yep. Okay. We're going to go through one of these again right away at the beginning tomorrow. But I am going to give you some to start on. If you get stuck when you get to these, since this was kind of at the end, we're going to do a couple right at the beginning, and then you can finish those tomorrow because they're not due till tomorrow anyway.